All right, so matrix multiplication. So I was saying it's not as easy as the addition. You can't just multiply each of the corresponding spots. It doesn't work that way. I always say it's like rubbing your belly, patting your head. Can you guys do that? It takes some skill. It takes some coordination to multiply. So let's start with the basics. So it says matrices A and B can be multiplied only if the number of columns in A equals the number of rows in B. Okay, so it says the product of a matrix with dimensions m by n multiplied by an n by p. The number of columns is equal to the number of rows in the next one. See how those inside numbers are the same? That means that we are able to multiply them. So whatever, if we cross those out, whatever's left is going to be our new dimension. So we're going to have m by p. So it's going to be an m by p matrix. So it says, can we find A times B if A is 2 by 3 and B is 3 by 4? Are the numbers on the inside the same? Yes, so we can multiply them. The new dimension will be 2 by 4, exactly. All right, so can we find the matrix product B times A? So B is 3 by 4, yeah.
So then for the two numbers, so when you have matrix and you're multiplying them, so then if it's any two numbers that are the same, you sort of cancel them?
It has to be the inside numbers. So if I have B times A like this, 4 and 2 are not the same number. I know that the 3's are the same, but the order of this matters. Okay, so if I do B times A, it's 3 by 4 by 2 by 3. So no, we are not able to multiply those because of it. All right, and then it says, well, what if we have x times y, and x is 2 by 2, and y is 2 by 10? Do we have the same middle numbers? Yes. So what will our new dimension be? 2 by 10. Okay. So you cannot move them around. We can't do y times x, but we were able to do x times y. All right, so multiplying matrices, it's a very complicated definition. It says in a matrix product P, which is A times B, each element, Pij, is the sum of the products of consecutive entries in row I in matrix A and column J in matrix B. Isn't that terrible? It's like the worst definition ever. Okay, so we're going to do lots of examples so you're going to understand what this means. Okay, so it says, suppose we have the following matrices. Compute the following. So W times X. So W is the matrix 3, negative 2, 1, 0, 2, negative 1. And X is the matrix 4, 7, negative 2, 5, 1, negative 1. So if I asked for you to add these matrices together, you would not be able to add them together because they are not the same dimension. Agreed? But we are possibly able to multiply if our dimensions have the same inside numbers. So let's think about dimensions. It's always rows and columns are like columns in a house. Columns are up and down. So the first one has 1, 2, 3 rows, 1, 2 columns, right? Do you guys see that? So we have 3 rows and we have 2 columns. So it's a 3 by 2. And this next one has 2 rows and 3 columns. It's a 2 by 3. So when we multiply these matrices together, what do we get?
But how do you multiply them together, though?
That's what we're getting ready to learn.
What is a matrix in the first place?
A matrix is a set of numbers.
But why would you?
This is what this whole chapter is about. It's so much fun things to learn. We can learn how to code messages. Like the NSA sends messages with matrices. Can you believe that? They're actually used quite a bit, and they're used to solve, you know how we did a 3 by 3 system and you guys hated that? Like finding X, Y, and Z? Not very fun, right? You could find a 26 system. You could find A, B, C, all the way to Z using a matrix. It makes it very, very speedy. All right, so anyway, so we're multiplying a 3 by 3. So I'm going to have 1, 2, 3, 1, 2, 3, 1, 2, 3. So we're first just going to set it up. So here's how we're going to multiply. It's going to be a little confusing the first time, so everybody make sure you're paying attention. Rodrigo, are you paying attention back there? You're ready? So we're going to circle the rows in the first one and the columns in the second matrix. So rows and then columns. And any location I'm in, so if I'm talking about this spot right here that I'm putting a red star in, what row and column is that in? It's in the second row and the third column. So in order to find that spot, I would use the second row and third column to find it. Okay? So I'm going to take my fingers, and to find that one spot, I would do 1 for my first number, -2 for my first number, multiply them together. What do we get? -2. When I take my fingers and I move them, I have 0 and -1. What do they multiply to be? 0. So I have -2 plus 0 gives me -2. That's what would go in that spot. There's lots of multiplying that we're going to do. Yes, Greta?
Why is it in the first row, not the second row on the second one?
It's in whatever row and column it's in. So if we're in the row and column like this, we're going to use the row and the column to find it. Okay, so usually we go in order. We don't just randomly pick one. All right, so let's start with this first spot right here. That is in the first row and first column. So we are going to use the first row and first column to find it. Okay, so take your fingers. Everybody needs their fingers out. So we're going to do 3 and 4. Do you guys see those are the first numbers?
Yeah.
And we're going to move. So the left hand's going to move to the right, and the right hand's going to move down. So I'm going to have 3 and 4 multiply to be 12, and then I move. -10. So 12 minus 10 goes in this first spot.
Wait,
We're going to do a lot of these. You'll get it.
Should we just put
Oops,
down
12.
2 or no?
You can. I'm just going to write the steps so you guys can see it.
how do we?
All right, next spot. We're still in the first row, but now we're in the second column. So first numbers, 3 and 7 make 21. Move.
Oh, I get it.
-2. 21 plus -2 is what goes in the next spot. Don't panic. You got this. You can write the answer. That's fine. All right, next up. First row, third column, right? 3 times -2. -6. Move. -2 times -1. 2. So I have -6 plus 2. It goes in that third spot.
How are we getting these answers, though? I don't understand that. How do we get that? Why that
Do the third one again. I missed it because I was looking right.
Okay, I will do. I got 6 more spots. Do you guys think you'll get it after 6 spots?
Yeah.
No.
I think you'll get it.
Absolutely.
All right, let me use a different color. All right, so let's say that I have. So I'm in the second row. So I'm in the second row, and let's say first column. All right, if I'm in the second row, first column, I'm going to take my fingers. I'm on 1 and 4. Those are my first numbers. When I multiply those first numbers together, what do I get? 4. Now I move both my fingers. So when I move to the next number, 0 and 5 make 0 and 5 make 0, which combines to be 4. You're correct. I got you. You're a step ahead. Does it make sense?
Yeah.
All right, now go to the next one. So now we're in the, let me write 4 plus 0 again. Get rid of my green marks. Okay, so for the next one, I'm still in the second row, but now I'm going to be in the second column, right? So I'm going to take my first spots, and I have my 1, oops, I erased. That's not good. I have my 1 and my 7.
1 times 7. 7.
Right, 1 times 7 is 7. And then I take my fingers and I move them. 0 and 1 make
7.
0, so I get a total of 7.
Hey, I get it now, Mrs. Fox.
You do, good.
And then wait.
All right, so what's the last spot?
So you do 2 times -2.
Nope.
4.
I do 1 times -2. I'm here, still in the second row, but
Oh,
now I'm in
you're
the
right.
third column.
You're right.
-2 plus
I would just
0.
But there's no. How do we get the third row?
All right, now we move down to the third row.
Okay, and then that's
Third row, first column gives me the third row, first column. So 8 minus 5. So 8 plus -5.
Wait.
Goes right there.
Wait, what?
All right, now take your fingers. Next one. Now I'm in the third row, second column, right? So third row, second column. 14 and -1.
14 plus 1.
So 13. Yeah, you always multiply and then you add those results together. All right, and then the next one. -4 plus 1 is -3. Good. So some of you guys will be able to do this without writing all the inside stuff. That's fine. We would get 2, 19, -4, 4, 7, negative 2, 3, 13, negative 3. That is the solution. That is the two matrices multiplied together. It will get easier. This is just the first one that you've done. Would you like to try the second one on your own?
Yes.
So we have x times y. So x is the matrix 4, 7, negative 2, 5, 1, negative 1.
But there's
5, 1, negative 1. And then y was 1, 4, negative 2, 3. So what are my dimensions?
You're doing that one.
Did I skip one? Ah. Oh, is there one down here that I didn't see it. So x times w, so x is going to be 4, 7, negative 2, 5, 1, negative 1. And w is going to be, what is w? 3, negative 2, 1, 0, 2, negative 1. Are we able to multiply them? So first, look at the dimensions. It's 2 rows, 3 columns, and this next one is 3 rows, 2 columns. So what are we going to end up with? A 2 by 2. So I always kind of draw my blanks. So I say, okay, I'm going to have a 2 by 2 in the end.
Oh my god.
And I draw it out.
Wait, can you rewind really fast? How did you get 2 by, because the 2, oh, okay.
Because those inside numbers are the same, right? So it's going to be the outside numbers, 2
But
by 2.
how do you get the second one? What are you doing? How do you know to cancel? What is that exactly?
How do I know what now?
How do you know to cancel? And how do you get a 2 by 2 with those
Okay.
2 by 3 and 3 by 2? Other than canceling, what's the method that makes it impossible to have it pieces?
Well, let's think about it. When we were moving our fingers, right, we were going like this. See how there's 3 numbers here and there's 3 numbers here? If you had 3 numbers here but only 2 numbers here, then you wouldn't be able to multiply. Okay, that's why those numbers on the inside have to be the same.
Wait, but
It's telling us when we move our fingers, we have the same number of spots.
why are we doing it sideways?
We only do things certain orders. All right, rows and then columns. We don't, so x times w, we keep as x times w. We don't do w times x. All right, are we ready? All right, so you guys try that first. Well, try all 4 spaces, see if you get it. This time you're going to have 3 numbers on the blank. So like the first one is going to be 12 plus 7 minus, or plus a negative 4, right? Do you guys see that? So first row, first column, 12, 7,
Okay.
negative 4. All right, try the other 3 spots.
Wait, where are you getting the 12? And how do you
So on the next one, we're going to do, we're in the second, well, we're first row, second column. So we use the first row and second column to find it, right? So we're in the spot, first row, second column. So we're going to take our fingers and we're going to match them up. So did you guys have 4 times negative 2 gives negative 8. Then we move 7 times 0 gives 0. Then we move negative 2 times negative 1 is 2. So in that spot, you should have negative 8 plus 0 plus 2. Did you guys have that? All right, now we go down to the bottom row. So bottom row, so second row, first column, 15, 1, negative 2. Did you guys get 15 plus 1 plus negative 2? And then we move. So we get negative 2, or sorry, negative 2, negative 10, 0, and 1. Did you guys get negative 10, 0, and 1 for the last one? All right, so your answer should be 15, negative 6, let's see, what is this, 14, and then negative 9. Did you guys get that? All right, so Ethan, I think you had negative 9, didn't you? Okay, did you find your mistake? It was on the top row, so that spot right here should be negative 8, 0, and 2. A lot of people, when they have the 0, for some reason they, like, yeah, so a lot of people will say 7 times 0 is 7. You know, they just like get in a hurry and they make a little mistake like that. So look for things like that. Okay, so let's try another one. So x times y. What are your dimensions? Okay, so Abby's saying not possible. Do we agree?
Yeah.
This is 2 rows, 3 columns, but this one is 2 by 2. Those middle numbers are not the same. So it doesn't work, so we write not possible. But let's think about why it doesn't work. If you took your fingers and you were moving right and left, up and down, right? Do you see how they're not matching up? I have 4 and 1 match up, 7 and -2 match up, but then what about this -2? What does it go with? There's nothing there. Okay, that's why it's not possible.
I've always wondered that.
Always. All right, so let's do the next one. 1, 4, -2, 3, and we're going to multiply by 4, 7, -2, 5, 1, -1. Okay, so x times y was not possible. Is y times x possible? Yeah, because this is a 2 by 2 matrix, and this is a 2 by 3 matrix. So we're going to have row, columns, like that, and they do match up, right? Those middle numbers are the same, so we're able to do this. Okay, what will our new dimension be? 2 by 3. So that's when I usually like draw it out. And I start matching things up. So take your fingers, right? So we're going to have 1 times 4, and then we move our fingers, 4 times 5. So we have 1 times 4 is 4, 4 times 5 is 20. So we get 4 plus 20. And then we move to the next spot. You guys with me? Christian, you getting it?
Not really, but I'm trying.
Okay. So in the next spot, we're using the first row and second column. So we take our numbers. So we have 1 and 7 match up, and we move. 4 and 1 match up. So 1 times 7 is 7. 4 times 1 is 4. The next one we do 1 times, what number does it match up with? -2. So 1 times -2 is -2. Those are the first spots. And we move both of our fingers. When we move both of our fingers, what are the two numbers? 4 times -1, which gives -4. Okay, now we're in the bottom row. So for all the things in the bottom row, we're going to use the bottom row of the first matrix. So we're going to have, match them up, -8 plus 15, right? And then we're going to have -14 plus 3. And then we're going to have 4 minus 3, or 4 plus -3, you could write. Does this make sense? So we're going to have -8 plus 15. And we have -14 plus 3. And we have 4 plus a -3. So our final matrix ends up being 24, 11, -6, 7, -11, and 1. We're done. Okay, how many of you guys got that? All right. How many of you guys were really close? You just missed one number. Oh. Yeah, so typically when I grade it, you know, like, let's say this was worth 4 points on the test. For every mistake you miss a point. So if you had 24, 10, -6, and then all the rest were right, but you had missed the 11, I'll have to count you off 1. Okay, so there will be little mistakes that you'll make, so just be kind of careful. But usually they're worth like 4 points. All right, so it says, note, the commutative property does not hold when you multiply matrices. So we saw that x times y wasn't even possible. So it was not the same as y times x. And if you look on the other page of notes, we did wx, but we also did xw. Were those the same in the end? No, this one's a 3 by 3 matrix, and this one's only a 2 by 2. Right? They weren't even close to being the same. Does that make sense? Do you guys remember what the commutative property means? It means like 2 times 5 is equal to 5 times 2. That works for normal numbers, right? We can move things around. But for matrices, it does not work. All right, a square matrix is exactly what you think it is. It's a square. It has the same number of rows as the same number of columns, right? And then the multiplicative identity. So what about multiplicative identity? We learned that a long time ago. So we said like 5 times something gives me 5. What was our regular multiplicative identity? 1. So most people guess for a matrix that it's going to be 1, 1, 1, 1, like that. It's not. It's not 1, 1, 1, 1. So there's something that will make it so that when we multiply by itself, or multiply by that identity, we get the same thing that we started with. Okay, so it ends up being 1s down the diagonal, 0s everywhere else. So it says it's a square matrix named with the letter I that has all of the entries along the main diagonal equal to 1 and all other entries equal to 0. So if I was doing the 4 by 4 identity matrix, we write it out as 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. I feel like a computer. 0, 0, 0, 1, like that. So do you guys see how there's 1s down this diagonal? This is called the main diagonal. So we call this the identity matrix. Now this is a specific identity matrix. It's the 4 by 4 identity matrix. So sometimes you'll see like I subscript 4, or we'll just write I. So if I had the 2 by 2, what would the 2 by 2 look like?
0, 1.
Close.
Oh,
1,
1,
0,
0,
0, 1, right? Okay. So let's test those. So it says when we multiply any matrix A by the identity matrix I, we get matrix A back. So this is true if we multiply it forwards or backwards. So in this case, it is commutative. If I have A times I, it ends up being the same as I times A. So it says multiply A by I. So A is 1, 4, 2, negative 3. So if I have 1, 0, 0, 1, the identity, remember I have rows in the first one, columns in the second. It's a 2 by 2 multiplied by a 2 by 2, so we get a 2 by 2. And we find each of those spots. So again, if you're in the first row, first column, use the first row, first column to find it. So we do 1 plus 0 goes right here. And then we have 0 plus 4 goes right here. And then we have 2 plus 0 goes here. And we have 0 minus or plus negative 3 goes here. So we're going to have 1 plus 0, 0 plus 4, 2 plus 0, 0 plus negative 3. Notice how even I use my fingers. It's okay to use your fingers to multiply. It's just the method that we multiply matrices. All right, so we have 1, 4, 2, negative 3. What was that? That was matrix A. So anytime we multiply by the identity, we better get exactly the same thing out. And like I said, it doesn't matter what order we multiply. So you guys can set this one up, but if you just want to watch, I'll show you what we get. We still have a 2 by 2. And we circle the rows in the first, columns in the second. And then we multiply. So we have 1 plus 0 gives me 1, right? And then 4 plus 0 gives me 4. And then I have 1 plus 2 gives me, not 1 plus 2, 0 plus 2 gives me 2. And then 0 plus negative 3. So again, we get 1, 4, 2, negative 3. We still get A out. So that is a case where the commutative property does work when we're multiplying by the identity. Okay, and then the last thing, I feel like I tell you guys these things all the time. I'm like, people do this all the time on the test. And then you know what? Every single year, people still do it all the time on the test. It's like, it doesn't matter if I tell you that people do this all the time on the test. So I'm telling you, don't do this. Okay, so if I have A squared, okay, that is A times A. A is 1, 4, 2, negative 3. This is not red and underlined. It is not 1, 16, 4, 9. It is not that matrix. Do you see what I did there? I just squared all the items, right? We can't just do that. We can't just square everything because that's not how matrix multiplication works, right? Matrix multiplication says that we multiply A by itself, and we do it in this funny method. We do our rows and our columns, and we end up with a 2 by 2. So let's find it. So if I'm finding A squared, I'm going to have 1 times 1 for my first spot, and then I move my fingers, 4 times 2 for my next spot. So I'm going to have 1 plus 8. See what I'm saying? And the next one, I'm going to do 1 times 4 for the first spot is 4, and then I move 4 times negative 3 is negative 12. So I'm going to have 4 plus negative 12. All right, and then I go to the next spot. So I have 2, and then I move negative 6. So 2 plus negative 6. And then I do the last spots. So last row, last column, 8, and I move 9. So your answer should be 9, negative 8, negative 4, 17. So if I make this 4 points on the test, and you write the answer is 1, 16, 4, 9, how many points do you lose? You lose 4 points. You do not get any points for that question because you did it totally wrong. Does this make sense? Do not do that. Don't be the person that just squares every single item. You cannot do that. So no, please don't do that. You never will, right? See, I say that and there's going to be like 10 people that will do it. All right.